All right, let's get started. Well, welcome again, everyone. Really excited to be joined here today with Dan Gerlanc. Dan and I did a podcast together for a new podcast that he started called Agents and Engineers. Dan is also very deeply technical, obsessed with agents, understanding sort of the new state of play. He was co-founder and CTO of .text, which owns sort of the open source package repo called Outlines, which helps structure generation. And today he is going to talk about kind of the repo as its role in making context available for your agent, and some of the things that you may or may not do that make it really possible to have great agentic runs. And it's really a core of agentic engineering. So there's not in today's session a ton of like, hey, here's how you do this. Like, we're not going to take you through like the mechanics like we did whenever John Berryman went through building the agent or whenever I was running Claude. But a lot of these tips and tricks, I think, are useful to understand high level how to internalize them. And I'm hoping for some really great conversation. So without further ado, Dan, I'm going to hand it over to you. And thanks so much for being on.
Yeah, thanks, Greg, and great to be on here. And yeah, like Greg mentioned, what we want to do with your repo for agents is in some ways make everything kind of as boring as possible, like the least amount of surprises. And so today we'll go through, is your repo ready for agents, and I came up with 7 high-level things that you can do or think about at a high level with some examples of how to get that set up. And a lot of these are things that I do in my own work. You don't need to have all of them or do them all to the same degree, but at the end of the day, what we're looking at is how do we establish this consistency and make it so really your repo remains a useful interface to the code. And before I jump in, like Greg mentioned, I also have a podcast that Greg was on called, and John Berryman as well, who did the previous Lightning Lesson. His episode is coming out tomorrow, called Agents and Engineers, where I talk with lots of folks, both building agents and developing using agentic engineering. So check that out. It's on Spotify, Apple, anywhere you can find podcasts. And if you're interested in being on the podcast or know someone who you think would be a good fit, don't hesitate to let me know. So I mentioned this kind of in passing, but the only thing your agent sees when it's first starting working with your code is the repo. So you're kind of starting from that at base 0 every time. And I think that's kind of a good conceptualization for how you think about preparing your repo for working best with agents. How are you going to make it discoverable as possible, or make it as easy as possible, given that an agent has a few different things it can do? It can read files, it can iterate through directories. Each of these is some number of steps. So to get to the answer as quickly as possible, how do we minimize those steps? So a general theme that you've probably seen if you've gone to any of the other Lightning lessons, and we'll see if you take Greg's course as well, is that we kind of have 2 different brains that we're working with. There's the LLM or AI, which it's kind of slow, but it's very powerful. You can write entire programs just by doing a one-shot line and let it go nuts. But at the same time, there's a lot of variance there. You do the same prompt twice, you might get very different things. So how do we kind of temper that? And that's where code and the automation side really comes in, where we want to have this powerful non-deterministic side when we need it, but at the same time, we also want this really fast iteration loop for things that we know are always going to work in the same way. And when we combine these two things, that's when we get a really powerful system. Use the LLM for what it's best for, and then use deterministic systems for what those are best for. And this theme will permeate all of these 7 different things that we'll go through here in terms of making your repo ready for agents. And these 7, I'll just go through them fast, are static analysis first, defining tasks, which sounds a little vague, but you'll see what I mean by that. It's more defining an interface for common things in your repo, a durable memory for agents, which means giving the agents a way to understand what's in the repo, skills, which everyone probably knows what agent skills are, but today we're going to talk about them in the context of your repo and working on your repo. How do we define skills that make it easier for agents to accomplish tasks in your repo? Observability, which is teaching your agents how to learn from the operational context of your code base. Like, how long does a request take, or how long does a function take to run? Verification, which is verifying that how the agent creates code is evaluated either by another agent or by a deterministic spec. We'll actually go through a few different ways of doing that. And then lastly, history. How does an agent understand how the repo has evolved? And some of this is going to be overlap a bit with durable memory and a lot of the other components. So ideally, these things kind of interact in a useful way. And as you'll see, the more we invest in one area, oftentimes it will bear fruit in making the other areas work better as well. So the first one in terms of static analysis is, I'm going to be slightly non-specific here because the static analysis you're going to need for your specific repo is going to depend very much on whatever language you're using. So if you're using a statically compiled language like Rust, you're going to be running things that are built into Rust, like Clippy and formatting. If you're using something like Python, you're probably going to be running something like Rough, that is a formatter and linter for Python. So each of these is going to be very dependent to the language and tools you're using. However, the important thing is that you actually set these up and use them. And my preferred way of setting this up actually is using a tool called prek. Prek is the Rust implementation of a tool you may have heard of called pre-commit. It's much faster than pre-commit. It's kind of like, if you're familiar with Python, it is like the UV of, as compared to pip. So it reuses environments, reuses tools, things like that. So it's very fast to set up and start. And it's quite useful because what it will allow you to do is install a bunch of hooks that anytime you have a git commit, all of these checks are going to run automatically. And this is useful because now your agents don't really need to know how to format the code that you're writing. Like, they don't need to know that you use a specific Python formatting, or if they start writing some code and commit it and there's errors, it's going to get automatically surfaced and then likely fixed in the next turn. And the good thing with prek is that it has all sorts of other built-in checks for things that aren't necessarily language specific. For example, you can check that there's new lines at the end of files, make sure that you don't have merge conflicts, things like that. And these are all very fast. And in short, there's not really a great reason not to use this. It's pretty easy to set up. I'll show an example here actually from using it in Python, which is a language I've used for a long time. And I actually have a gist that has the exact pre-commit here that should show up here. It's a pretty short file, basically identifying that we're going to run a linter, we're going to make sure all their dependencies are up to date, and then we want to make sure there aren't weird things going on in the files, or that we've left something like a key in the commit. And these all run basically so quickly that you're not going to notice anything's happening. Now, some people will also put things like tests in their pre-commit checks or prek checks. Personally, I'm not a huge fan of doing that just because tests can take a bit longer to write. So usually I'd rather just tell the agents to run that automatically. But your mileage may vary. Some people like to make sure that their tests are run as part of this, but personally, I usually don't add that. One thing I will add with this is I do generally like to also run this in CI. So I know some folks don't necessarily still do pull requests or things like that. I do like them sometimes to be able to actually run my checks again independently in a fresh environment. And so if I am setting up pull requests like on GitHub or merge requests on GitLab, what I'll do is make sure that all of the prek checks run and then all my tests run there as well. And so that way I kind of get a double verification that everything is good to go before merging in new code. So are there any questions from the chat we have, Gray?
Yes, there's one from Rahul actually, and I did send sort of a link to the GitHub repo for prek if people weren't familiar with it. But Rahul says usually the agentic loop has plan, do, verify tempo. The pre-commit failures will be noticed in the verify stage? ?
So they should be noticed as soon as code is being written and committed. So depending on the agent, it may structure your code in logical commits, which I think most of them will do these days. So it ideally should surface it before you even get to a separate verify stage. And that's part of why it's a good practice, because you want to solve these sooner than later.
Yep. We can take that one for later, though, about kind of like people's agentic Git practices, because I'm sure everyone's sort of mileage varies. And it's an interesting topic in terms of maybe how you set up your agents MD or Claude MD in terms of like what you tell your agent to do, or even if it's in the context of your conversation. So we'll save that for later.
Yeah, definitely. Right,
one other question before you move on, Dan, if you're up for it, is Dimitri asks, like, do you use like an LSP plugin alongside with prek for anything?
Yeah, I do like using language-specific LSPs. Either like for Python code, I'll use the Python LSP. Similarly for Rust and Go, I've used them. So I am a fan of those. And they can actually help avoid some of the problems, or sometimes using the LSP will reduce the number of errors you see fixed when you get to your prek or pre-commit checks.
Yeah, that's another question. It's like, what do you contain your sort of agents in? Are you using a terminal, an IDE? Like, yeah, people's environments are all very different as well.
Yeah, for sure. Yeah, that's quickly evolving, right?
But I think technically speaking, rough is like actually an LSP, like under the hood. Like
Rough, I think, does provide an LSP, but it may be limited in terms of what it checks. But
primarily,
I think you're correct that it does provide an LSP. There are some new, I think a new one out of Meta, Firefly. And there's also, I mean, another thing you can, I don't have it in this file, but some of what you'll get from an LSP as well as you would get from a type checker, something like MyPy or Ty, which is made by UV, but personally, I'm not always a huge fan of aggressively typing all my Python code just because it tends to constrain it to work a very specific way. So, but I know some people who swear by using those, and it will get you a lot of convergence with your the LSP when you start using that.
I think we're good.
All right. So that's number one. Make your checks, your static analysis, anything relevant for your language kind of as fast as possible, and automate it. Like, don't worry about telling the model to write code following PEP 8 or whatever, things like that, or just by it should be baked well enough into the models at these points, and then just enforce it with these kinds of tools. Like, don't waste tokens on trying to solve that, or context on trying to solve that. So number two, and this is something actually that I think will is very important to getting good results and also to having your agents operate more quickly, is providing an obvious interface for how to do things in your repo. And so I call that task interface. And I was inspired somewhat here by, there was a GitHub article back a while ago that they call scripts to rule them all. I'll just bring it up here. And the idea they had long before the AI days was that all of their projects have these 7 different scripts. And basically, if you know how these different scripts work, then you know how to do different things in the repo, like get all the dependencies set up, or set up or reset the project to an initial state. And when I was starting to work with agents and repos, I thought of this article again, and a lot of times I would see the agents using something like npm instead of pnpm to start. And I said, why don't I just encode all of this into a bunch of scripts and then make sure it goes into my agents MD, so that the agents are always doing the exact same thing to either set up the repo or run tests. They don't have to remember exactly the invocation of PyTest that's needed or things like that. So in concept, this is pretty simple. Basically, there are 7 different tasks that they recommend in the GitHub article. I don't think you necessarily need all of them. Some of them are like setting up a console, for example, may or may not be relevant to your project. But other ones like Bootstrap, which is set up the project from anew, like getting all the dependencies or setting up the project to a different state, those are things you definitely want your agents to know how to do. And you don't want them to have to make it up or figure it out every time, because if they get these things wrong, they might not install your dependencies right, or they might not run all the tests or things like that. So by making this unambiguous, essentially, you do 2 things. One is you reduce the number of tokens that's needed to actually solve these, and then 2, you reduce a failure surface of saying, oh, we ran the tests, but maybe not all the tests were run. So this is the number 2 item, I'd say, in terms of setting up your repo for agents.
It's a great pattern, and I will say, as a brief aside, one of the last people to actually contribute on that repo was Mike McQuaid, who, if you guys know or don't, or maybe not, he's been a long-time contributor since like 2009. He was a principal engineer at GitHub. We overlapped whenever I was there on the Homebrew project, so he knows a thing or two about reducing developer friction.
Yes, and reducing developer friction is often reducing agent friction these days.
Exactly.
And you may notice there is a little quiz as you go through here. So we'll have all these slides available on the repo after this, but you can go through and take the quiz with your own repos or systems. And at the end, it will tell you which to focus on first. Mm-hmm. All right, on to the next. So the title of this slide I took from Greg's recent book. Docs are the API between turns. And what this means is that we want to encode in documentation how the system works. And if you've worked with LLMs for any amount of time, you know that they only know what is injected into the context. You're otherwise starting anew every time. And so when you have a repository, it's very important to provide a context as to how that repository works or what those conventions are. Now, you can decide not to provide these things, and a lot of times the agent will kind of go and explore the repo and figure it out. But the thing you leave to chance at that point is that your architectural choices or preferences or different things that determine how you want the repo development to move forward and be in line with how things work historically might not be respected. Now, agents, I mean, now you could have them and they could still not be respected, which is something we'll get to solving later. But in all of these things, what you're trying to do is increase the likelihood that an unpredictable stochastic system is going to do the thing you want it to do. And one good way to do that is to provide these high-level patterns. And things like architecture are things that actually models are less trained on in some sense. Like, they implicitly will understand like what's a 3-tier web application architecture, things like that. But in terms of how exactly that architecture works within your application, some of those things can be subtle. And because of that, like, let's say you're using row-level security, right? Because you're using something like Superpower, something like that. Like, getting that wrong can have some serious consequences, but making sure that it's set and applied is a very small thing to note, but also something that might not be figured out if your agent doesn't hit the right file. So encoding this information is super important. Now, how do you make sure that you have this information and how make sure that it stays relevant? That's another tough question. And there's a lot of people working on this and a lot of different degrees of complexity in which you can attempt to do it. I mean, I think at the simplest level, one thing you can do, and this we'll get into as well, where we talk about skills for the repo, is make sure that when you are generating changes in the code, that if there's anything that needs a change in the existing documentation, like at a minimum an architecture.md file or a spec, that those changes also get reflected there. And then you have essentially a declarative view of the system. At the other kind of extreme, there are systems like DeepWiki that Devin, which is kind of a software automation platform, provides, where basically once a day they'll go and build an entire wiki of your repo. And that's something that can then get accessed by MCP. And you can also essentially build your own version of that, where you could have a recurring task that runs once a day or once a week and runs in CI or wherever you run agents, and then goes and creates a PR, for example, with these changes. So a lot of different ways to do this. I mean, I did some research into other open source solutions for this. I wasn't super impressed with anything I saw, but if there's anything that people have used or are fans of for doing this, like in a more automated way, that's not built into like the skills that we'll talk later, then definitely interested to hear about that as well.
Yeah, this is an interesting topic, just as like an aside. Depending on like what I've been building over the last year and a half, like I've taken a couple different approaches. For things where I was like using a less goal-oriented approach, where I kind of like baked in updating the as-built architecture into every sort of like goal run,
Yeah.
I would often force myself to sort of manually do this as a step to make sure that like my mental model of the system was like evolving versus having it be completely automated, because when it's completely automated, you're like less likely obviously to go and kind of like poke at it and figure out like if you truly understand what's happening, especially depending on like the sort of velocity of change in like your repo or your system or whatnot. And I don't think that there's like a necessarily like a one size fits all process. Like of course you could build it into CI, right? Of course you could have it be sort of like a rule that's instantiated somewhere or a skill. I think the most important thing is that you have it and you actually like look at it and try to understand it at the right level of granularity for, what your intent and purpose is. And I say that because like, as you're going deep, and you might be managing a lot of different agents parallel, maybe you're like bouncing across projects, like the one thing you need to kind of understand is, well, like for the next thing I'm going to build, like how does it fit in? Like how does it fit in as a piece of a puzzle with what I've done before? And, is the architecture of how I've designed the thing, whether it's a CLI or CRUD app or, whatever case may be, need to evolve. Plus, if you're a heavy user of at references to produce context, like it's always nice to kind of have at least a working mental model of like where things are, how you've broken down your repo, right? Like how you've organized your different components or subcomponents of your system. And it is one of the things that I like to pay attention to most, for that reason, because like as Dan mentioned, and I think it's really important, it's like, you don't like often there's a lot of grepping and globbing around by these agents, and like you don't need to waste like hundreds of thousands or millions of tokens depending on how big your code base gets, just like pointing your agent at the right direction.
Yeah, that's definitely the case. If it has to, like, especially if you have a very large repo, I mean, in a small repo, the agent can reconstruct things pretty quickly, but as you get into larger repos, having good documentation that tells the agent where to go, I think, becomes even more important. And yeah, I agree with what Greg says, that there's not a one size fits all for doing this. How often does your architecture change, right? If it's changing super fast, then there's a lot of volatility in the system. Like other, you might have other things to think about then too. So maybe you should just be doing it manually at that point. at least, yeah, I think is there's no one size answer for this.
The one last final comment I'll leave is like, obviously it's best in my opinion to co-locate like a document or documents like these in your actual code base. Because at any point you could see the last time there was a commit made to it, provide the agent a range of SHAs and be like, what's changed since then, and have it be able to easily sort of do a diff against, that last commit head where you committed your sort of architecture and like what's changed. So I am very much a proponent of stuff like architecture docs being in your repo.
Yeah, same. I think if you can have, having them in your repo automatically ties it to the state. So having it somewhere else, I mean, if the system's good enough, then sure, but it's one more thing to get out of sync. And you also then need to introduce tools or something else immediately to give the agent access to it. Like the deep wiki is only MCP accessible, for example. So, I mean, I'm sure you could get it from MCP and put it into your repo. That's probably what I would do. So the next area is repo-specific skills. And the idea here is, I think, both simple and deep in that the things that encode kind of the most important things that you're doing in your repo are things that you want to tell the agents how to do. And this isn't too different from going back to the task interfaces like setup or bootstrap or run tests. The difference here is that we're providing programs in English and sometimes with additional scripts. So this is kind of going beyond purely deterministic and getting into repeatable patterns. And like I must have row level security on my mind because it's here. I mentioned it before, but like including different checks for what the threat models are for your repo, or as we'll get to in another one of the items, being able to know what are the different telemetry systems that your production server is writing to, and being able to pull those down and correlate those. The agents aren't necessarily going to know what they are, or they're not going to have the credentials to do it. So what you want to be able to do is bake in, hey, here's how you're going to access this, or here's the things you need to access, here's how you'll access them, potentially provide scripts and ways of injecting credentials, things like that, and evolve these as you build your repo. I mean, think of this as what is the tooling that you would build for yourself to be able to investigate or perform tasks in your repo. How do you build these for agents? So, I mean, I think that's, in a sense, a simple concept, but an important extension of the pure deterministic checks. And this gets into starting to mix kind of the deterministic and less deterministic, which is, as we go from the earlier to the later numbers, we get in from like the pure deterministic into the mix of the two. And building kind of on the last item of setting skills within your repo, one thing that I've been thinking a lot lately, Matt Rocklin, who was the creator of Dask, was on the Agents and Engineers podcast, and he was telling me about how he had rewritten Dask actually in Rust, and how one of the first things he does anytime he is starting to work with agents is he asks them how to instrument the system such that they will then be able to fix it later. And so for something like Dask, this was providing scheduler information, function, timings, things like that. But for a web application, having access to logs, traces, things like that, it's going to be very specific to the kind of system you have. But the short of it is, you want to make sure that your agents, or there is telemetry or logs or whatever you're using that your agents can observe, and then that you teach them how to do this. And some of this interacts, of course, with the previous thing we went over, which is skills for agents. So oftentimes you'll be combining these two to provide access to these. Now we're on to the final two. This is the meatiest of them, because I want to leave the last one not too complex. And this is kind of a mix of repo convention as well as agentic tooling. And the idea is that when you're developing new code in your repo, you don't want the implementer to be the only system that's evaluating your solution. And there are different ways of doing this, ranging from more like prek pre-commit, like one of which is a project called RoboRev, which was created by Wes McKinney, which basically how RoboRev works is you can tie it into register a hook with a repo you have, run it locally, and then anytime there's a commit, it is going to take the model of your choice. You could hook it up to Claude Code or Codex, GPT, anything you want. Anytime there's a commit in one of these repos, it's going to run an adversarial review on that commit. And it basically does the same adversarial review on every commit. So it's pretty easy to get set up. It works pretty well, but every time you have a commit, you have to go and then check this. So there is some automation, but at the same time, you have to go and babysit it somewhat. Another option is a system that Greg has worked on called Dead Reckon. And it inverts some of what you would do in RoboRev by requiring you to actually define what done is ahead of time. And I'm not going to go too deep into how to work with Dead Reckon. If you take the full course with Greg, I'm sure you will get solid experience doing this. But the general idea is that you define an independent state of doneness with the help of an LLM, of course. And that is then kept separate, essentially, from the implementer. So your implementer can't go and change your tests just so that they meet done, things like that. It can't cheat. And this is, in some ways, kind of an opposite of how something like RoboRev works, where, I mean, there is an independent tool, but it's being triggered off exactly what's happening. This is really requiring you to take the effort up front and say, hey, this is what done means for me. And then reviewing that carefully and iterating towards that. So, like I say, there's no real right or wrong answer to a lot of these. I think some of it depends on the kind of problem you're working on. But in general, anytime you're building new code, the models, even the best of them, get things wrong. And so the real best practice here is using an independent reviewer, ideally another model class at a minimum. So if you're using Anthropic, Claude, try using Codex to review, or an open source model, and make sure that you're at least at a minimum reviewing the results for issues with another model. Do you have any other questions, Greg, before we get to the final?
Not yet. There was some commentary about Max was talking about kind of like one of the things that he did, keeping a development log from before when we were talking about like docs being an API between turns, and then Rahul asked about just using scripts in skills. And yeah, I mean, like kind of like the theme of this entire talk about sort of like where determinism helps. I personally think like if you were able to canvas, like maybe you went to skills.sh and you saw like every skill that's been produced, like the percentage of actual skills that are more than markdown and have like deterministic scripts or processes in them is like a very, very, very small number. I think they're still very underexplored. But I found a lot of value using them, and there's like an example I shared, and I don't think we've ever talked about it on a Lightning Lesson, but like I have this lore skill that mines your like SpecStory histories to actually generate skills for you, and it uses a lot of determinism. I think they will become very popular, very much more popular as people kind of wrap their heads around like what you can actually do with them. But no questions yet, unless something else popped in. So you can keep going.
Yeah, definitely deterministic code and skills. I built some skills for editing. I have, or trying to find useful segments to share with the podcast, and a lot of those have determined. I haven't quite gotten it working very well. I still find that a human editor works better than the LLM, but encoding some of that logic as a script actually reduced the amount of time that was needed to avoid it having to try to use FFmpeg and things like that. So
totally. Yeah. We did have a timely question just now from Rahul asking if you've ever used C4, which I believe I looked it up. I hadn't used it. Is like a documentation MCP, I believe.
I have not. I'll have to check it out. Yeah, that is another area. I mean, I think that's like the MCP side of those versus things that are natively in the repo always worries me a little bit. Like things that make, like LSPs are pretty quick, but things that have like a graph of your code, things like that. Like if your code base is changing quickly.
Oh, okay, actually, Rahul's clarified. It's just a model for visualizing software architecture.
Oh, okay.
Yeah. There's an O'Reilly book on it. See?
Oh, yeah, there you go.
Yeah. No, I haven't used it specifically, but I have a feeling that a lot of the principles and best practices in that book are probably encoded in the weights in these models. Since we know, especially Anthropic has, paid a $1.5 billion settlement for copyright infringement. So chances are we're kind of getting the benefit of it anytime you ask, Claude to make a mermaid or ASCII diagram without even knowing it.
Yeah, but I'll check out the book with my O'Reilly subscription.
Luckily, you can check out the book without one because
there you go.
Is actually, it seems to be open source, or it's Creative Commons.
Oh, cool. And anything else?
I think we're good to go.
Okay. So last one, try to keep it easy to end things off. But personally, I am a fan of using conventional commits for the commit history. And if you've worked with an agent anytime, you will notice that they do like to look into Git history to see how things have changed, have developed. And historically I had not used these, but since working with agents using these specific kinds of commit formats, they actually will allow you to identify, for example, when was a bug fix made, or when did a breaking change happen, things like that. So they encode more information at the top of the commit, which I think for agents is especially useful. For people, once you're pulling up the commit message, you're probably looking at most of it anyway. So I historically had been less of a user of these, more just write a 50 character commit line or less and then detail. But this, I think, ties into as well with how are you documenting your repo, and at any point the state and time essentially log of what happened is usually your commit history. So making that as legible as possible to agents, I think, is good. I also generally try to keep my history linear, avoiding doing like merge commits, things like that, especially now because you can generally tell agents to resolve most gnarly Git merge conflicts, things like that. So that's another aspect that I try to do in terms of making the repo history as obvious as possible. Like, don't have a bunch of different paths to go down unless it's really needed, because you've got tons of collaborators and things happening super fast, things like that. And that's all of them. So there, for everyone here, the homework task is, of course, to go and check your repo and run the scores, see which areas you can fix. I mean, I think generally a lot of you can usually deal with some of them, like pre-commit, prek setup pretty quickly, things like that, as well as getting things like your scripts, your scripts to rule everything, install, things like that. Those are usually pretty quick fixes. And then I like to compare. I mean, you can do this very strictly, look ahead of time and after. Is your session size going down? Are you getting your installs done in one way versus a bunch of different ways by your agent? If you're using SpecStory, that's a good way to see this and track it over time.
Yeah. Well, this is awesome. Look, I think it's a superpower to do a lot of these things well. It's a brave new world that we're working with agents in, and a lot of this stuff, I mean, it's always been sort of hygiene, that sort of like, the best product development teams, engineers sort of like assumed. It's in some cases even more important now because of the velocity by which you can produce change to software. And so ensuring that, like, you have your repo set up correctly, understand the mechanics of how agents work, they're good at doing what they're not. And of course, you think about your job as the verifier of correctness, whether or not that means that we're all turning into engineering managers or something sort of similar. It's like all the basics of how you're going to be successful agentic engineering in the future. So I know sometimes it doesn't make for like the most flabbergasting talks, but in some ways, we're talking about like trying to build software over time, over a long time, and having it work. And so like these essentials, you just really can't ignore. So I would open it up, unless there's anything on anyone's mind, like to just questions. Feel free to come off camera, ask the question out loud. I'll look at the chat. You can use the last 10, 15 minutes to engage. Dimitri has a question. I'll just read it out loud. He says, do you use some task systems like Backlog MD to track the task, just define acceptance criteria, definitions of done? How do you think is it effective in practice? I started to use it and found it pretty useful to work with the tasks in a more systematic way. It's funny. I'll comment on this because before we got on, Dan and I were like talking a little bit about like task management as it relates to today's like frontier model. and then we can hit your other points, Dimitri. So in the yesteryear, which was maybe like 9 months ago or something, when the frontier models weren't as on the frontier as they are now, I saw and leveraged and attempted to use a variety of different sort of like work breakdown structure task management processes, for lack of a better term. Some were like, rolled by hand. Others, like I explored, although never used, like Steve Yegge's beads. There was another product that kind of came out, it's open source. I think it still exists when Cursor was taking off, called Taskmaster. And I would say early iterations of models, I did try to take a spec, break it down into sort of like a phased plan at different levels of granularity, and kind of use that as a loop to kind of keep myself honest in terms of like what was being implemented, what was done, like checking boxes and markdown and whatnot. Um, I think these days, though, like depending on the sort of unit that you're trying to review, if it's a goal where you're sort of specifying a more, non-deterministic sort of plan up front and letting like the model exert its high reasoning ability, I find myself gravitating to that approach a little bit less. But what I will say is that in addition to some of these architecture documents, I've found keeping sort of like a running change log, even if it's not a change log for like external release, to be a very effective pattern to kind of, supplement what you might have at the granularity of a commit at a sort of like higher level readable sort of like medium for human consumption. I do think like whether or not you're using like a meta harness like Dead Reckon to try and do something like definition of done up front, or you're using kind of like the built-in loop like, slash goal and codex or Claude Code or equivalent, that defining constraints or checks, whether you're judging it or a model's judging it up front, is a very, very helpful pattern. And you actually can lean into more of what the underlying like LLM is capable of doing than you were ever able to in the past. So, like everything, every week, month, day, things are changing. But I think the most important like concept, Dimitri, at least in my mind, is to one, sort of understand where you're going, have a way of sort of specifying that outcome moving forward and being able to verify like your intent was achieved, whether that's through manual verification, different types of test suites, or what have you. One last comment, and then I'll let other people respond or ask more, or if we miss something, we can get into more depth. Is one of my favorite bathroom robe prognosticators, Bob Martin, who wrote Clean Code, just had a really banger tweet about the fact that basically he set up his entire environment so that he doesn't read any of the code any of his agents write anymore, and he basically relies on data from all sorts of different ways that he has pre-constructed tests, whether they be unit tests, system tests, end-to-end tests, Gherkin tests, you name it, to kind of give him the data that obviates the need to sort of like write code. Um, that was a long monologue. Any other people's impression or commentary on Dimitri's question?
Does Betty Am have her hand
Yeah.
raised?
Yeah, hi. So I don't have a specific comment on Dimitri's question, but first, Dan, thank you so much for this talk. It was really, really helpful. It's so good to hear how other people work and organize. And Greg, you've said in the past how, maybe this stuff isn't sexy or exciting, but for me, I think it's critical. So thank you for overcoming your sort of maybe hesitancy to sort of go public with this. So I really appreciate it. The other thing I'll say is listening, particularly in this talk with you, Dan, about how you try to separate the sort of LLM variability from the deterministic stuff. I literally kind of feel vindicated about, for decades as a developer, as a builder, I've always had a pretty, for lack of a better word, mechanical way of dealing with feature building or whatever. And I have to say, over the decades of my experience, I've almost always come across resistance where people are like, this isn't important, speed is much more important, blah, 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 blah. And the way I feel vindicated is my mechanical, step 1, step 2, step 3 is now so useful for these mechanical LLMs. So, like I said, I feel really vindicated. And so hearing how you do it here, now I have to convince, like, I love my system. I think it's great. That's why I do it. And so now I have to try to convince myself or determine just how much I want to disrupt what I'm used to doing to maybe, like, for example, I still use pip and I know I should use UV. And maybe I now should go look at prek. And I need to figure out, like, how much do I want to go through that discomfort as I make that transition. So I just wanted to thank you for sharing all that and maybe helping me make that decision.
Thank you. Definitely use UV. That's all.
Yeah, that's
one thing, but otherwise, yeah, I think working with LLMs, a lot of it gets into system engineering. And like Greg mentioned, the question of are we all managers, things like that. We're a lot of the systems for managing work output is what we're now applying to work with LLMs, and it's just moves a lot faster.
And another thing I might comment on based on what you're saying about becoming a manager is I love to code. It's the thing I do. Like, on my worst day, coding makes me feel better. So I love to do it. And the more that LLMs can code better than I can, the less coding I do. And it makes me sad and cranky. And I've never wanted to be a manager. And every time I've been approached for a managerial position, I've always said flat out no. And yet here I am with these AI tools with Claude doing like 95% of my day is managing it. And I really dislike it, to be honest. But this is where we are.
This is where we are.
Well, there's nothing that prevents you, Betty Ann, from like coding on the side or like working on implementations, especially for places where perhaps like it's not very rote, right? Like if you're working through like performance optimization problems and have to do a bunch of research to figure out, like, I don't know, like a better way to solve a problem than you're going to get out of the box. I think that's where like a lot of our creativity can still be expressed. Now, I don't know if you're going to be like implementing the linear algebra to make your, I don't know, machine learning system work better, but yeah, I mean, like, there's nothing that prevents you, right? So just always be aware that there's that, and like you could make a system that would enable you to, write or type more of the code. Like if you remember all those old books, like Learn Python the Hard Way, where you like literally had to like type like the entire program in to do it. Like there's no reason you couldn't make like a harness to do that.
No, you're right. But since all of my career, all I've ever heard, the biggest pushback I've always gotten was, you need to be faster. So since an LLM is just lightning fast, I just can't imagine anyone's going to tolerate while I indulge in like a fun hobby.
Yeah. Max, do you have a question? Thanks so much, Betty. I always appreciate your engagement.
Yeah, thanks a lot, Dan. That was super interesting. And I'm curious. So coming back to I think it was your last slide on version history and how that can be useful to agents. It reminded me of the work by Adam Thornhill, I think he's called. So I haven't read his book yet, but it looks really interesting. It's called Your Code as a Crime Scene. And I'm not sure if it's only about Git history, but it's certainly like one aspect that goes into analyzing like what are hotspots, what are places where like things don't quite like seem to work and people come back to, and like God classes or modules or whatever. And I'm curious if anyone has like both experience with that approach. As I said, I haven't read the book yet, but also like it seems like there's a lot more to explore when it comes to version history, Git history, and so on. I haven't really delved into that too much, but I'm curious if people have experience on that or any other thoughts, comments.
Max, I missed the book name that you said. I apologize. What was it again?
Oh, it's called Your Code. Let me
Is it
pull it
crime
up.
scene?
Your Code as a Crime Scene. I think it's this one here. And I think they also have an like a SaaS thing called Code Story, I believe.
And just draw the connection for us one more time. What was the question
So
related to that?
yeah,
The version
so
history?
I've only been following him on LinkedIn a little bit, and he talks a lot about basically, well, it's kind of the underexplored dimension of what makes code difficult. Like we always look at basically the snapshot that is the current commit, but basically diving into the history and seeing the hotspots of where changes keep being made and so on identifies like a much richer picture of where your code is unhealthy. And I'm just curious if anyone has explored that, especially with AI and LLMs.
I personally haven't, but historically, I mean, I'm familiar with kind of like probably what I could infer is some of what's in that book, just from my background at both GitHub and then running a software engineering intelligence platform. I mean, like something like recursing through like, get blamed for a specific part of a system, for example, and seeing like, how many times some component was changed or some set of functions or something can tell you a lot about maybe like the evolving nature of that system, or like where requirements were very unclear or like morphing a lot. I mean, like there's all sorts of measures too when it comes to code quality and health that I think, depending on who you ask, probably people have different opinions, like cyclomatic complexity, things like that. I'm sure there's some touching on. I haven't done anything like that recently with like LLMs to understand like where does the agent go back and continue like modify. But I could tell you that like depending on your skill with like particular language or syntax, like if you're not smart about decomposing problems, like you might end up with very large main files in certain languages, which probably then, if you were to go back and analyze like how your system would then evolve over time, you'd find a lot of crime scene evidence. But I don't know if anyone else on the call has any experience going deep, kind of mining their version history to understand, the change rate or like hotspots, as you might imagine, something like, you might be able to visualize from an analysis like that. But now I have something to go look at because I have
Sounds like a no, but I'm
Yeah, I have not either. I mean, I have talked to people as well in doing the podcast and asked about measuring cyclomatic complexity and things like that. Is this a way to guide the code generation as well as it's happening? I haven't seen anything really about people doing it or evals around it, but I did think it was interesting, but I haven't seen it applied or analyzed, which doesn't mean it's not out there, but I haven't seen it.
Yeah, I mean, like my thinking on that notion, I mean, it's probably a lot different from when we were spending $150 an hour on labor to produce code. But like, if you were able to, I don't know, observe an incident in production and get a bunch of traces and understand like, why, and it led you to understand your code base, and like there's, too much like, not like incidental complexity, you might want to, spend some time to refactor it because like that's the source of the issue. That's like bringing down your app or service or whatnot. But like I think unless you tie it to some broader meta metric that you're trying to optimize, like just doing that for fun is probably not where most people spend their time. But like if you're having a lot of outages and incidents related to the complexity of your code base and it's really hard to reason about, then I think probably doing that kind of analysis would be very helpful, for sure. But yeah, for what it's worth, I just put that book title into Google and I got this, which no warranty. Like it looks like maybe a pirated version, but it was like one of the first versions that came up, so you can kind of like look at this, I guess. Yeah. But cool question. Thanks, man. You always ask great questions.
Yeah.
All right. Couple more minutes, 2 more minutes. Any final questions, thoughts, or comments? Going once. Going twice. All right. Well, thank you everyone for joining. We'll get the recording and the slides in the repo, and really appreciate the engagement. And thanks so much, Dan, for coming on. I really appreciated it. So thanks for the work you put into today's session.
Yeah, it was great to be here. Yeah, and thanks everyone for all the great comments and joining us here today.
Yeah. All righty.
Bye-bye.
Take care. Bye-bye.